Hey guys, today we're looking at target 5D for our review for our test. So we are looking at computing probabilities of independent, dependent, and compound events and use those to interpret data. Remember, our target 5D is really all about these tree diagrams. Okay, so looking at our first example, we're going to use the tree diagram and given information below to answer the questions. So I started reporting the following data regarding ice cream consumption. Of the people who prefer sugar cones, 77% order chocolate ice cream. So we look at 77% here, right? Prefer sugar cones, so they order chocolate. Remember, 77% is as a decimal 0.77. Using that, I can find what will go here. Remember, 0.77 plus that blank will equal 1. So I'm going to subtract 0.77, and my blank equals 0.23. Or 0.23. Either way. Then the next thing it says is, of the people who prefer waffle cones, 48% order chocolate ice cream. So again, prefer waffle cones, order chocolate. 48% is 0.48 or 0.48. Again, I can fill in that bottom number. 0.48 plus some blank equals 1. So I'm going to subtract 0.48. And my blank equals 0.52. The last thing I'm going to do in order to finish filling in my table so I can answer my questions is find the numbers at the end. And remember, we multiply to find those numbers. So I have prefer sugar cone and chocolate. And it's going to be 0.6, right, times 0.7. 7. Which, when we multiply those together, we get 0.462. And again, you can always use a calculator for that. Prefer sugar cone and vanilla, I have 0.6 times 0.23, which is 0.138. And then prefers waffle cones and chocolate, 0.4 times 0.48, and we get 0.192. And then 0.4 times 0.52, and we get 0.208. Okay, now that we have our whole tree diagram figured out, I can start looking at my questions. So question 16 says, on the tree diagram, which decimal should be placed in the blank space labeled V? Well, we already have that. That's supposed to be 0.23. So we're just going to write that in there, 0.23. Easy. Explain what the probability of V represents. Okay. Remember, let's look back at this. We have our 3 different sections. This is our simple probability of A, where this shows us what A is. This is our given probability, B given A. This shows us what B is, and this is our AND probability. Okay. So B is probability of B given A. B is ordering chocolate, down here, ordering vanilla, given you prefer a sugar cone. Okay, so it's just B, then A. Read them backwards. Let's erase. At some point, this will work. Right. So it's the probability ordering vanilla, given they prefer sugar cones. 18. Find the probability that they prefer sugar cones and order vanilla. Well, again, I'm just going up. I'm going to look at my and probability section. Sugar cones and vanilla is this number right here, 0.138. Or, right, I can move that decimal, and it's 13.8%. And then 19, what is the overall percentage of people who ordered chocolate ice cream? So again, I'm going to go back up to my chart. Chocolate is here, 0.462, and here, 0.192. I'm just going to add those together. .462 plus 0.192 is 0.654 or 0.654. Again, moving that decimal place twice, I get 65.4%. This is important because it does ask for the percentage. That is one of the points on the test. All right, looking at number 20. Madison needs to order her Happy Meal. She has 3 main choice options that include hamburger, chicken, nuggets, or a turkey sandwich, right? So that's my first choice. So I have hamburger, chicken nuggets, turkey sandwich. Just going easy like that. Madison also has 3 side dishes that include french fries, applesauce, or yogurt. So french fries, applesauce, or yogurt. So each of these, I get french fries, applesauce. Sorry, my board is not working, so I'm trying to just use my finger. French fries, applesauce, yogurt. French fries, applesauce, yogurt. French fries, applesauce, yogurt. Okay. So how many options do I have? I'm going to put the number next to it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's what my first question asks. How many combinations can I choose from? I can choose from 9 different combinations. Okay. So then, C, calculate the probability of Madison choosing a turkey sandwich on Friday and then choosing a hamburger on Saturday. On Saturday, turkey sandwiches are not available for purchase. Okay, so the first thing I'm going to find is choosing a hamburger on Saturday. Okay. If I look here, I can choose any of these 3 options. Okay, so I have 3 options out of the 9. So I can choose option 1, 2. Oh, sorry. Sorry, I forgot. I didn't do the first part of the question. Eraser, please. Sorry about that. Sorry, let's look at... Why are they shuffling door? Turkey sandwich on Friday. So again, same type of thing. For turkey sandwich, I can choose any of these 3 options, 7, 8, or 9. That makes more sense. Which is 3 out of 9 options. And then on the next day, I can order my hamburgers. Please move up. But remember, turkey sandwiches are not available. So now with hamburgers, I have 3 options, but there's only 6 total options. And that's 1, 2, and 3. And then remember, and means multiply. When I multiply those together, I do get 1/6.